This segment of the course will deal with how to get the beer into the glass once the draft beer is packaged and into kegs. How to dispense the perfect looking and tasting glass of draft beer. We will explain the differences, the mechanics, and the reasons for deciding which system to install when building your business. There are three primary dispensing systems with minor variations. First, the direct draw unit. Second, the air chute beer system. And third, the recirculating beer system. Each system above requires a propellant to move the beer from the keg through the cold refrigerated lines to the faucet and into the perfectly poured glass of beer. The following propellants have been used and improved upon over the years. First, air compressor. Then, carbon dioxide. Next, nitrogen, never used alone. And fourth, mixed gas, combination of CO2 and nitrogen. Critical for quality draft dispensing is pressure and temperature. From the time the keg is filled by the brewery to the perfectly poured beer in the glass by the bartender, the product must be refrigerated, even in the lines while dormant overnight. The beer is cold and under pressure, both controlled within limits. We will divide dispensing into two modules. First, the three types of systems, and then the propellants. Today we will cover the three types of systems. First, the direct draw units. This is a self-contained refrigerated cabinet purchased from an equipment manufacturer, delivered to a job site, and plugged in. It is generally, not always, placed behind the bar. When using half barrels, these units are available in 1 to 4 barrel sizes. However, if you change the standards on the top and the faucets, you can pour up to 19 beers out of a 4-barrel direct draw unit. These are the standards. These are the faucets. And here is a picture of a direct draw unit pouring 16 beers. Just load the beer into the cabinet, tap the keg, and enjoy. A propellant is connected to the tap. Open faucet, pour beer. Next is the air chute beer system. This is a cross-section of an air chute beer line. The system is generally installed by a qualified beer installation company with trained techs. This system is chosen for its simplicity and is usually a one-station system. It is not a cabinet delivered to job site. It is a combination of many parts, fittings, tubes, and clamps. And it's usually a 1 to 2 day installation for 1 to 2 techs, depending upon the number of lines or faucets, and must be a short distance from the walk-in where the beer is stored. The theory here is that the cold air is blown from the walk-in through the 3-inch tube using a squirrel cage motor. This squirrel cage motor here, there's your squirrel cage. This connects to the 3-inch tube in the walk-in. It is usually positioned in front of the evaporator coil of the walk-in refrigeration system. The squirrel cage motor connects right here at the end of the 3-inch tube in the walk-in. Should be placed in front of the evaporator coil to the refrigeration system of the walk-in. Your walk-in is here. Your faucets are up here. These are your beer lines. The cold air is blown through this 3-inch tube up to the bar, returns down through this 4-inch tube right here There is the space between the 3 and 4-inch tube to bring the warmer air back to the walk-in to be cooled one more time and sent back up again. The maximum line run on an air chute beer system is 15 feet with a straight run and no angles. If a 90-degree bend is necessary in this air chute, a 90-degree bend is necessary in this air chute, you must subtract 6 feet from your calculations. Therefore, the faucet must be 9 feet from the walk-in. It is suggested, when designing your restaurant, to oversize the refrigeration system to allow for the additional heat load of this beer system. This is a variation of the air chute beer system. These are faucets through the wall of the walk-in. There's your walk-in, and there's your faucets. This is a variation where the faucets are mounted right on the wall of the walk-in, generally facing the customers at the bar, thereby reducing the line run to about 1 foot, the thickness of the wall. It's an extremely efficient system, but the walk-in must be just behind the bar. This is an expensive space to dedicate to a walk-in for beer storage. However, often used where no basement is available. And thirdly is the recirculating system. The recirc system has also been called the long draw system for its ability to deliver beer from the walk-in to the faucet. In theory, no matter how far away the faucet or bar may be, no matter how many stations there are, and no matter how many lines or faucets there may be on each station. What you're seeing here is a mock-up of a recirc system. The major components here are the walk-in with the kegs. This is a power pack mounted on the side of the walk-in wall. In this power pack is a tank right here of propylene glycol, a motor, and a pump. The outside wall of the walk-in is right here. The beer lines are here going up to the bar. These are your beer lines going up to the bar. This is your refrigeration loop coming off of the power pack going into the bar, picking up the lines of beer going out to the bar. So it's a complete loop. And as you can see, the beer, as always, is always under refrigeration. Otherwise, there will be hot spots and the beer will pour wild and foamy. The power pack is a tank of liquid food-grade antifreeze. Right there. It's called propylene glycol. And that's your recirculating motor and pump again. You must give attention to the pressure and temperature when designing these long, complicated systems. The line diameter, or sizing, is adjusted for maintaining proper flow at the faucet. If not, this is another reason for the beer to pour wild and foamy, thereby wasting expensive product. A well-balanced system, properly installed, should pour a perfect glass of beer every time, from the first beer of the day to the last beer before closing. In the early 80s, we started using a copper recirc approach. It was a soldered copper recirc approach. At that time, manufacturers of beer systems were using flexible plastic recirc tubing with hose clamps. This left the recirc loop open to deterioration over the years, limiting the pressure the loop could withstand and the possibility of leaks in the future. The purpose of the loop is to keep the beer in the lines cold. This loop recirculates 24 hours a day, all the time. Since that time, the manufacturers have improved the quality of their lines, and we have gone back to using the lines supplied by the manufacturers. The product recirculating is propylene glycol, a food-grade antifreeze. Ethylene glycol is used in your car for antifreeze. Glycol allows us to pull the temperature of the liquid down below freezing and still recirculate it running parallel with the beer lines in the insulated wrap so that the beer is always the desired temperature. These are your recirc lines. There is a double recirc loop in this Python because of all the beer lines. These are your beer lines. You'll see the color in the beer lines. That gives the installers the opportunity to know what line they're working on, no matter which end of the Python they're on, whether it's the walk-in side or the faucet. This is a vapor barrier. There's your insulation. Next, an experimental recirc system. Also in the 80s, since beer equipment manufacturers and installers were using a refrigeration condensing unit to pull down the glycol to acceptable temps, we decided, why not try using the refrigerant gas and recirculate that through these lines if they were copper, and we used copper. Thereby, this becomes the evaporator in a refrigeration system. Just wanted to show creativity is possible. We've gone back to using glycol on most installations. It is easier installation, keeping in mind finding and training techs is always an issue in the real world. Towers and faucets. All systems described above have towers and/or faucets, from the single barrel direct draw unit to the most elaborate multifaceted faucet tower. The restaurateur must decide what fits his or her pocketbook and decor to add the frosting on the cake. Here is the tower to the beer system being installed this year, right here in downtown St. Pete at Stillwater's Restaurant on Beach Drive. As you can see, it can get elaborate. The choices are only limited by your creativity. This is all the customer sees, so choose wisely. The pour. Carefully tilt the glass under the faucet. Allow the beer to slide down the side of the glass, being careful not to create excessive foam until the end of the pour. That's when you tip the glass back up to bring the proper amount of head or foam desired, serving the delicious looking and tasting glass of draft beer. This requires practice, so pour and serve or pour and drink. Enjoy.